Hi, my name is Mark Brooks. I am the author of the book Christianity from a Spiritual Perspective, which offers an explanation for why world religions exist, but does so without the use of doctrine or dogma. The premise supporting the book's explanation is that reality is fully wave-based. This presentation gives you three observations that show how a wave-based reality could actually be true, by showing how matter could be composed of waves. We're all familiar with the two types of waves, longitudinal and transverse. Longitudinal waves vibrate, while transverse waves spin. But does a wave exist that simultaneously does both, that both vibrates and spins? I propose that this type of wave exists and that it forms the foundation for the creation of matter in the universe. Here's a diagram to illustrate the idea. How would a longitudinal and a transverse wave interact? Could it occur, say, when a detector is placed in front of the slits of a double slit experiment to determine the slit through which a photon passes? Let's assume that when an interaction does occur, the spinning transverse wave causes the longitudinal wave to spin as it vibrates, which causes the two ends of the longitudinal wave to flare out and double back upon itself, forming the torus's familiar donut shape. Additionally, the longitudinal wave's vibration action causes the transverse wave to vibrate itself within the torus as it spins, forming a standing wave inside the torus. This illustration implies that when we observe wave-particle duality in a double-slit experiment, we may actually be witnessing the creation of wave-based matter on a quantum scale. But how does matter formed from a photon become matter on a larger scale? To answer this question, let's look at a 3D printed model of a torus. You've probably seen the digital animation of a torus, but have you ever seen a model of a torus in its physical form? Let's examine the one in the photograph. The first thing that impressed me with this physical torus was its construction. Whenever I pressed on the top of the torus, it wouldn't collapse. This torus had structural integrity, but what gives it this support? If you look closely, you'll see that there are multiple small rings arranged in a uniform pattern around the large torus's central core. The large loops of the torus pass through these small loops as they pass through the core. Consider this illustration. It shows that as we move from a universal level of scale in the upper right-hand corner to the scale of a human being at the lower left, we can see that each large torus in the cosmos contains a large number of smaller tori. For example, the torus that forms a galaxy contains billions of stars, each of which may contain multiple planets that orbit within its own torus. Could the small tori of multiple suns and planets form the central core of a galaxy's torus, giving it structural integrity? The second thing I observed with the physical torus was that I could make two different shapes from the same 3D printed material. In this photo, we see the traditional donut-shaped torus on the right, and on the left we see a globe-shaped torus, which is not commonly shown. Now let's compare these two shapes with the shape of a large torus, such as the magnetosphere that surrounds our planet. It contains multiple layers of loops, not just the one loop that we see in the donut-shaped physical model. The magnetosphere seems to be a combination of both the donut and the globe-shaped torus. Fortunately, we can demonstrate how this would work with another model. To replicate the torus of the magnetosphere, we need to integrate the two torus shapes. This integration can be done by looping two tori together. This photo shows what two integrated tori look like when they're 3D printed. Here's what they look like after they're shaped. You can see the donut-shaped torus on the outside and the globe-shaped torus on the inside. But haven't we seen this shape before? Yes, we have, in the proposal of the third type of wave. It's the same shape. So based on these physical models, the magnetosphere around the Earth could be a combination of multiple tori, with the donut-shaped torus on the outside providing the structural integrity to shelter one or more globe-shaped tori on the inside. Now let's apply these observations to the magnetosphere's upcoming flip. I can imagine what you might be thinking right now, but let me add a small twist. The first physical torus model showed that multiple smaller tori integrated within its core provided it with structural integrity. If we extrapolate this concept on a cosmic scale, we can see how the universe's celestial bodies could be integrated with one another. We can also see, based on the joined double torus model, that if a torus in an integrated cosmic grouping needed to flip, the donut-shaped torus could remain in its place without breaking the integration, while the globe-shaped torus made the change. But what happens when a torus flips? To demonstrate this, let's use a third physical model of a torus, this time in the form of sweatbands worn around an athlete's wrist. The two sweatbands shown in this photo are exactly alike, but the orientation of their two white bands is different. This is because the sweatband on the right was turned inside out, pulling the fabric through the slit that you see on the right-hand side. What this shows is that when a torus flips, the orientation of the torus changes by 90 degrees, in this case with the two white bands moving from a north-south direction to an east-west. Now let's consider this in terms of the magnetosphere. What would happen if a globe-shaped torus flipped and its poles changed from a vertical orientation to a horizontal one? I'll leave that discussion, as well as other observations in this video, up to science. Thanks for watching. I'd like to express my appreciation to the organizers of the 2020 Science of Consciousness Conference for the opportunity to present to you today, and hope everyone in attendance here finds information of value to help them in their work. Best wishes for your future endeavors.